Hi, this is Dr. Vic. I would like to explain the magic behind a derivative. If you're planning to take a calculus course, most probably you're terrified. And you should be, because it's a very complex subject. However, let's make the concept of a derivative easy and fast to understand. Let's suppose we want to compute the derivative of this function, x squared. X squared is a parabola. What's the meaning of a derivative? A derivative is how much does a curve change for every small change in its horizontal axis. This is the definition of a derivative. If you see here in the numerator, we are computing the change in the value of the y-axis for every small increment in the x-axis. And this difference we divide by the increment in the x-axis. So a derivative is a quotient. We just simply divide the y-axis by the x-axis. And then we take the limit of the horizontal axis to 0. So we are pretty much computing a quotient, again, y divided by x, and we make x as small as possible. In other words, a derivative is a tangent, the tangent to the curve. So let's replace the function x squared in the definition. X, we have to increment it by a small increment x, and this has to be squared. Let's go back to the definition. We take the original function x squared and we add a small increment in x. That's what we are doing here. And then we subtract the original function and we divide all this by the increment in x. If we expand this term, we come up with this. We can cancel x squared and minus x squared, and we come up with this. We divide by delta x, and we come up with 2x plus delta x. We take the limit. Taking the limit means that we equal delta x to 0. So this goes away. And here is the result. The derivative of this function is 2x, meaning that for every small change in the horizontal axis, the function x squared changes 2 times x along the y-axis. Thanks for watching. See you soon.